Good morning, all. Sorry that today it's just got delayed for 5-10 minutes. Sorry for that. And we'll be starting today with the Big-Ip DNS. All can hear me? Can you please tell me?
Yes, Raman.
Very good.
Yes, Ramna.
Thank you. Please mute your mic so that if you like to ask any questions, please you can unmute and you can talk. Else, please keep it muted so that I can talk. Okay, today it's about Big-Ip DNS. Previously, it was called as like Big-Ip GTM. GTM means a Global Traffic Manager. So FI has got many products which are available on the market. One is in very famous. It is an LTM, Local Traffic Manager. The second one is a GTM, that is a Global Traffic Manager. The last one is like they have many other products. ASM is also been there. I was delivering that ASM training previously. Demo I just given that in the last 2-3 weeks back, I guess. So that was an application security manager. Like that, they have so many products are available on the F5 platform, and the F5 platform is running on Linux only. And so the GTM we are going to talk about today, that is called as Global Traffic Manager. They renamed it as the domain name server, like that. It's a DNS server only. So DNS is a very integral part in any company and all over the internet also. DNS is going to be like domain name service. Domain name service has been offered by the servers called the domain name servers. The domain name servers, without the domain name servers, we will not be able to connect any servers on the internet. Internet, because that very simple logic, I can just say something about the DNS is that we can't remember all the IP addresses which are there in the websites in the internet. So what we do normally, we will create a name and the name will map it out with an IP address. The public IP address will get mapped. So that is called as a DNS. Very simple logic. It's like a table which has been created and kept and monitored and modified and it been maintained properly by the DNS authorities. Google DNS is the open DNS is the every company has got their own DNS in their own company. Like so we can create our own DNS server. That's not a bigger issue. Like we can create it on the Windows server itself, or we can create it on the Linux servers also. But most of the DNS, whichever it is available on the market, and which has been maintained by the ISPs, Internet Service Providers, and I can just say that 85 to 95% are running on Linux platform only. So why DNS? What is the requirement for the DNS? Why we are talking about the DNS so much? And what will happen without DNS in the internet industry? And what will happen? What are the plus points we are going to have that? And how we are going to get trained up with the DNS things? Because whoever has done the system administration, they will be going through this module definitely. And it is a mandatory for that everyone should understand the DNS. In Windows platform, it's called as like many DNS types they have Windows people, and the Linux we are having the IP DNS. We are just having the TCP DNS domain which will be creating on this. So whatever we are trying, so this meeting is being conducted through the zoom.com. So zoom.org, I guess. So Zoom is a domain name, and the Facebook.com, Twitter.com, Google.com, Gmail.com, NASA.gov. Many domains are there. Many domains are there. That domains we are going to see that about. Without a domain name, it will not be easy for us to find out the server and services, whatever it has been offered on that. So a single site may be containing multiple domain names as well. Multiple domain name servers may be running for that to bring the content for you. Like, so that is quite advanced thing which we just need to know that. And I would like to tell you some of the news about that. Internet DNS, we have a 13 DNS servers are there in all over the world. They have been dispersed in all over the, like according to the country as well as the continent side, they will be keeping the DNS servers over there. And those are all called as a root DNS servers. The root DNS servers are very important for all the internet connectivity everywhere. If the root DNS servers are getting attacked by the virus or spammers or hackers, then you will not be getting any site on the internet. So it has been completely protected properly. So we will be seeing about the DNS protection also in Big-Ip. How Big-Ip has come into the picture for the DNS means like every other product they are releasing, so they can release it for a DNS server also. It's as simple as that. They have an LTM product, they have an ASM product, they have an APM product. Like that, DNS product is also been that means a GTM product. GTM means a global traffic manager. Why does it become a global? Because of that we are going to talk about the entire world which is getting connected to that. So now we are opening up our laptop and we are start typing that gmail.com. We'll go to the gmail.com and we'll check our mails. How does it getting resolved? Because of that, our computer has got already the DNS servers mapped to that. Either your ISP DNS is mapped, or you can even map it out to the Google DNS 8888, something we can map it out. Or one more thing is the open DNS that is called as the 9999. That also we can use that. So any one of the DNS server is very much required for us to talk to the DNS, talk to the internet, and to retrieve the data, mails, sending mails or receiving mails or surfing over the internet, getting into the websites and all. That is very much required for that. So how Big IP DNS is going to work? What all the main components are in the Big IP boxes, and how much memory we require, and how to configure that type of DNS servers on this Big IP boxes. And can we activate the LTM along with the DNS? Can we activate the ASM along with the DNS? These are all the solutions which we are going to see today. This is also one of the DNS server. We can take it as it is. And it's very easy for us to configure everything on the GUI based, graphical based. If you are very good enough that you can go with that CLI also. Big IP has got its own CLI, that is a command line interface is there. That CLI has been controlled by the TMOS, means traffic manager shell. It is a TMOS operating system they are having. So if you know the commands of the TM shell, traffic manager shell, then we can configure the DNS on the Big IP boxes itself. Everything is based on Linux only, so there is no, like it's not so much hard that you can learn the CLI which has been offered by the TMOS or something. So before going into the product informations and the configurations and all these things, so let us start with the what is DNS, very basic things. Let me start this one. If I So what is DNS? DNS is a directory of names that match with the numbers. The numbers in this case are IP addresses which computers use to communicate with each other. The domain name system resolves the names of internet sites with their underlying IP addresses, adding efficiency and even security in the process. And the last, like the internet itself, the directory is distributed around the world, stored on domain name servers. Generally, they are referred to as DNS servers for short, that all communicate with each other on very regular basis to provide updates and redundancies. So this is about the DNS. What is DNS and how does it works and where it is being stored? What is the DNS servers names are called? Where in the internet is being stored, like that. We just seen that. That's like a table mapping the IP addresses with the names of it. That is nothing but the DNS. You can say the next. DNS servers and IP addresses. Each domain can correspond to more than one IP address. In fact, some sites have hundreds or more IP addresses that correspond with a single domain name. It's possible. For example, the server your computer reaches at www.google.com is likely completely different from the server that someone reaches from another country. Okay, like so the way they are reaching it, the way they are reaching the server, because google.com has been hosted on many servers. That many servers will be having that many IP addresses. So that all the IP addresses will be mapped in the DNS server so that the people will not having any problems. They will be reaching near to their own server. Means like if I'm in Bangalore, I'll be trying to reach the Singapore server. If a person who sits in Africa somewhere, he will be reaching it nearby the Johannesburg server. Like that, London people will be reaching through the London. This is a normal, common, like a common criteria to reach the any servers. It's not only the web servers. Any servers people are reaching on this. So this is how the things are being worked out. And another reason for distributed name nature of the directory is the amount of time it would take for you to get a response from where you're looking at for a site. If there was only one location of the directory shared among millions of probably billions of the people looking for information at the same time, that's a problem. If I am typing that google.com in the sense, it may be if it is contacting only one server in my one place in the sense, everybody will be typing it because it's all over 24 by 7 operations are there. If it is a daytime in the Bangalore in the sense, it will be nighttime in US. So people will be working on night also like. And if it is a night, I'm working on the night. People will be thinking that I'm working on a daytime only. Why do I require more servers and all? No, not like that. we require to maintain it for a 24 by 7. So it should be the distributed DNS service. We should not be restricted to that one location or something, physical location. Better we make it multiple servers, which is belongs to their own local location. Near to that local location, it will be easier. So that's why the distributed DNS server concept has been there. Next, what are the types of DNS servers? We are talking about DNS servers. A non-authoritative DNS server. Non-authoritative name servers do not contain original source files of the domain zone. They have a cache file for the domains that is constructed from all the DNS lookups done previously. If a DNS server responded over the DNS query which doesn't have original file is known as non-authoritative answer. Whenever you are opening up your Windows command prompt or Linux terminal, when you just typing like that NS lookup and enter, when you start typing that www.facebook.com, it will say the non-authoritative server. So that non-authoritative answer means that 8888 which we are using commonly as a DNS server, that is a non-authoritative. It doesn't contain the records of the original server information. Like facebook.com, when you're typing it, the facebook.com has got its own IP and its a content and other things. This entry will not be there in 8888, means a Google DNS. The Google DNS is actually contacting another DNS server to get that information and is giving it to us. That's why it is called as non-authoritative. The next one is an authoritative DNS server. An authoritative DNS server is a name server that has the original source file of the domain zone files. This is where domain administrator has configured DNS records for a domain. Authoritative DNS server can be master DNS server or its slaves. It can be anything. Authoritative means who is having the entire records of a particular site. That's called as an authoritative. So authoritative will be having the original records about the site information, IP mapping. Non-authoritative will not have that at all. It will try to contact another DNS server and it will get that information, fetching it, and it will give it to us. So that is called as a non-authoritative DNS server. The next, recursive DNS server. Recursive DNS server does by its name, it recurses, which means that it refers back to itself. The recursive server will check to see if it has a cached DNS record from the authoritative name server and still has a valid time to live. If the recursive server does not have the DNS record cached, it begins the recursive process of going through the authoritative DNS hierarchy. Means we can set up this recursive DNS server. When I'm setting up this, I just need to give that authoritative DNS server configured. Means either I will give it the Google DNS or Open DNS, something like. I'll give it out. Whenever there is a first query has been made, it will talk to the authoritative only. The second time, the same query if I'm making it. Say for example, I'm making on a facebook.com first time. That first time recursive DNS will look for its own table. Facebook.com is not there. So it will forward the query to the authoritative guys. Authoritative DNS will come back with the IP address information. When it is give it back to us, the user, sorry, the recursive DNS server will store that information inside. Next time, when you try to reach the same DNS query or something like that, it will give it from your own recursive server. It doesn't look for any outside. That is information. It's very faster. And only thing is that we just need to have some more memory to store all the sites. In a company, what we do normally, we will keep it as like a recursive so that the people will be project wise, they will be reaching certain servers only always. So their query will be reached very fast so that we will be keeping the recursive. The last one is caching only. Caching only DNS server does not contain zone information or a zone database file. The caching only server only contains information based on the results of queries that has already been performed. So it's more or less you can just say it as like same only. Recursive DNS server and caching only DNS server. There are four types we see there. One is non-authoritative. Second one is authoritative. The third one is recursive. Fourth one is caching only. I just listed only the four servers here because these are all the main type of DNS servers when you try to make it out like that. You know, the categories we can just make it out like that. So there are many other DNS servers as well, according to the work which is the DNS server must be doing, that they will be giving the different names for that. But it is enough, like when you go as generate terms, like these four are important: non-authoritative, authoritative, recursive, and caching only. So if you are clear with that, we can go to the next slide. How the domain tree has been maintained. See that this is a root. Root will be a dot. Small dot is a, can't see that I guess. Okay, then from there is a dot net is a dot ru, something like .com, .org, .tk, .gov. These all called as first level domains, or we can call it as top level domains, TLD. You can just say that. Inside the .net, there is one Modi server is like Yahoo is Google is my site. My site is there. So like that, it will come like that. Yahoo.com. The dot will be the root. Yahoo.com like that. Google.com. And here myhk.org. Okay, medis.js. Something like that it goes. Like that. You can take it as GOV. GOV will be like NASA.gov. You know, like Indian websites, Indian government websites will be seeing that .gov like that it will come. So from this we will be creating this. These are called as the second level domains. And the third level domains is like that. It will be like rs1.madis.net like that. It will www.yahoo.com, www.google.com. This is the third level domain. First level domain, second level domain, third level domain. Normally we start from here only. www.madis.io, mail.madis.io like that. mail.myhk.org, client.mysite.com, www.google.com like that. The dot will come in the root. So the root is the one, it's the dot. From there we will be able to make it up that multiple levels of domains. This is how the domain architecture goes on, hierarchical domain tree. You can take it as. Then I have to talk about something on domains and zones. What is a zone and what is a domain? Domain we just seen that .com, .edu, .org. These are all the domains. Okay. .org domain, .com domain, .edu domain. Under the .com, we just see fi, fi.com. This is the root, fi.com. Under the fi, I am having .com domain. This is a .com domain. That's dotted blue color dots as are there. No? That is a com domain. fi.com domain. It's under this is fi.com. Under that, there is one more zone. I'm creating the tech.fi.com. That is called as a domain like that. Tech. This is a tech. This is fi. This is com. So techfi.com. Like that sun.com, Microsoft.com. Like that it will be going. This is called as a domain and zones. Very simple to understand. You know, root is staying there. Under the root, there are many .edu, .com, .org, .gov. Like that it will keep on going. Under that, the companies will be putting their own name. fi.com, sun.com, Microsoft.com, redhat.com, CentOS.org. Like that it keep on going. Under that, we can create our own domains. Like according to the departments, we'll be creating the tech.fi.com, sales.fi.com, support.fi.com. Like that, it will keep on creating. Next one, how the DNS resolution, name resolution process, how does it works? You know, so we are just typing that from mobile phones, Android mobile phones or iPhones. We are just typing that something, the name of the server or something like that. It goes to that through that. How does it works from our laptop or desktop, from a server also, like we just used to type that. How does it work? The numbers are there. We just need to follow the numbers only. Let me take the annotation. It will be easier. This is the number one. Number one, the client, he is the number one. He makes the query of www.fi.com. The second, it will go to the LDNS. It is called as LDNS. LDNS means local DNS. Local DNS, it will try to resolve it with the local DNS. Okay. Local DNS. First, this is the first step. It will talk to the second step, means it will talk to the local DNS. Once it is talking to the local DNS try to find out whether we have the record of fi.com. It doesn't have the mapping. So what it does, it will forward this query to the root name server. Root name server is nothing but a dot. It forwards it to that. After the root name server find out that belongs to the .com domain. It is sending it back to the LDNS. You just need to talk to the root .com domain. .com domain server. .com domain server is here. This is a .com domain server. This .com domain server, again, my LDNS is forwarding the query to .com domain server. The .com domain server comes back to that. This is F5. Okay, so you just need to talk to the F5 DNS. So this is the fifth step. My LDNS is talking to that F5.com, and F5.com finds out that what is the IP address of the F5.com. That is what I was querying. F5.com it queries. Then once it is got the F5.com information, IP address, this LDNS will pass the information to me. The LDNS will pass the information to me. Means I am getting that as a sixth point. Sixth step. Seventh step, what? My PC will directly talk to the F5.com. This is the steps involved. First step, I am typing www.fi.com, talks to the local DNS server. Local DNS server immediately talks to the root DNS server. The root DNS server comes back and say that it is belonging to .com domain. Please go and talk to the .com DNS server. It provides the IP address also of the .com DNS server. My local DNS will go and talk to the .com DNS server. .com DNS server find out that I am searching for F5. So it says that F5 DNS server is this IP. Please go and talk. So the fifth step is it is talking to the F5 server, F5 DNS server. The F5 DNS server coming back with that IP address of the original www.fi.com. Once this information is received by the local DNS from the F5 DNS server, it gives it back to my PC. The PC directly talk to the web application server. This is how the resolving the queries, either you are doing it through the mobile phone or you are doing it through the laptop, desktop, or maybe through the server, something like that. If you are doing that, this is how the process is there. There are 7 steps involved. 1, 2, 3, 4, 5, 6, 7. So I guess it's clear. The next one is, let's see. The same thing, like it's another one more slide saying about the same thing. Client is typing that fi.com local DNS it goes, and the local DNS is talking to that root DNS give the IP of the .com server. .com server coming back with the FI name server. FI name server coming back with the IP address of the query. Then the client is directly talking to the FI server. Like that. Next one. How does it work with the GTM? Maybe we will come back to this later, but still I just wanted to give it to you like a small introduction about that. Instead of putting the FI name server, we will be placing that GTM server. FI GTM will be placed on this place. So once it is FI GTM has been placed, the GTM will be doing the load balancing as well. It will find out whichever the server is having the least queries to get answered. So it will forward that query to that, then it will pick up that IP, then it will give it to us. So we will see this later. Okay. So this is about some of the technical information. We just need to see that. We've seen a basic DNS and how the resolution works. What are the types of DNS we've seen. How we can introduce a GTM to that. We've seen that. Now we are going to see the DNS registry summary. Third quarter of 2020 closed with a 370.7 million domain name registrations across the all top level domains. It's an increase compared to the second quarter. Domain name registrations are grown by 10.8 million. Just see that 10.8 million. It's increasing every year. And the top level domain name registrations were 160 million in the third quarter, something like that. These are all compared to the second quarter. Country code. Country code means .in. We are having that. .au means Australia. Whether it comes up. So how much it is increased on that one? It is keep on increasing. And .com and .net TLDs, top level domains, increased how much? It is like 163 million domain names or registrations are done. So every day there is keep on domain registrations are happening. Why? Because of the new servers are coming up, new sites are growing up. Every site requires its own domain name so that we can able to reach that particular server without having any problems. So all the domains need to get registered with the central authority. When it is getting registered, they are having this all statistical reports. So it is keep on increasing. So that's why we require to understand the DNS servers and who is making the DNS servers, how to maintain them also. Next. So this is a graphical representation of the one which we see in that 370.7 million Q3 2020 closed with this much of domain name registrations. And this is about that company registration. .com and .net domain name registrations are this much. And the next one, top 10 largest TLDs by the number of reported domain names. .com is on number one because all commercial sites will go with the .com, Facebook.com, Twitter.com, like moneycontrol.com. Okay, so money involved. So everything is like whenever you're just seeing that, so see the .com is a 150 million. I can just say that it's a 150 million has registered .com, and .tk is 27 million, .cn is 24, .de, .net, .uk, .org, .nl, .ru means Russia, .icu, something like that. It keeps on going. It's depend on the like that how much it has been made, how much the query has been made, how much the registrations has been made on top level domains as well as the second level domains also. You can just see. Next one. This is a graphical representation of the domain name registrations. Top level domains are 370 million. Next new generic top level domain that is called as an NG. Others are 34. See how much it is in .shop, .ap, app, .vip, .club, .wan, .online, .site, .top, .xyz. There is a domain called .xyz is also there. .icu. This much has been registered nowadays. So that is an 8.1 increase. Something is going on. This is a Verizon has given this kind of the report which I took it from their site actually. So to understand this, why we are talking about this much about the statistical report in the sense we are in a position to maintain this much of a sites and this much of an information we just need to store it. We never know that the customers are reaching which domain and all. Accordingly, we just need to tune up our systems to talk to these domains as well. And we need to maintain the proper connectivity for that. Thereby, the GTM comes into effect. Okay, next. And it is like a comparison again. Like this is .de, UK, NL, FR, French, Australia, Canada, yes, something like B, US, Japan, Taiwan, something like everything has been coming up. Nowadays we are having the .in sites, edu.in, something will come up. In means India. Like that, there are many other countries are also making that top level NG domains, top level CC domains. These are all comparison charts. You can go through this. Tokyo has got so many. NYC, New York, and Berlin, Bern, Kapin, Kulin, so many other Africa, Amsterdam, Hamburg, Paris. Everything people are nowadays registering with the new names. It's not only that .com or .org or what is that .gov or something like that. There are many other sites are also coming up. Like the domain names are coming up like .tokyo, .nyc means my site .tokyo. I can create that. My site .nyc. Something like that. I'll just create. Okay, so let's see something about the, let us come back to the business, the FI GTM, Global Traffic Manager overview. Overview in the sense, how does the GTM is going to work out and how we are going to configure that and how it's going to maintain our sites perfectly. We can install it on our site for to maintain our information about the DNS server information and all to give it through the GTM, it's possible. The GTM is now referred as DNS, cutting edge modules offered on FI Network's Big-Ip platform. GTM simply tells you the best IP to route to based on metrics for the URL in question. That IP can be almost anything really, but usually it's an actual server or a virtual IP that fronts the multiple servers. The main configuration element in a GTM is called as a wide IP or WIP. For short, as of my significant other looks like YP, you can say. It's not an IP, it's a YP. Okay, that's jokes, okay, no problem. There are many configuration elements that works in a concert with a WIP, but at the base of it all, it's a wide IP. WIP equates the common URL, your rule balancing, and example www.yourcompany.com. A pool or pools are also usually attached to the WIP, which contains IPs that is intelligently resolving. This is about the how the GTM has been working, what are the GTM concepts of the, how we are going to understand this global traffic manager will be working, how does it behave when there is a query comes inside, and to find out the query about the DNS, something like that, to find out some of the informations about the some of the site or something, how do I reach, where do I go, what is the IP address of that server, like that. So whenever query comes in, like WIP will be responding that the real IPs for that. Next, some of the key differences between the GTM and LTM. LTM is a local traffic manager. GTM is a global traffic manager. Biggest difference between the GTM and LTM is traffic. Doesn't actually flow through the GTM of to your server. That's what. LTM will be allowing the traffic to go through the LTM to reach the servers, but GTM doesn't allow that. GTM just resolving the names and giving it. GTM is an intelligent name resolver, intelligently resolving names to the IP addresses. Once the GTM provides you with an IP, once the GTM provides you with an IP to route, you are done with the GTM until you ask it to resolve another name for you. Means the job is over. Once your resolving is done, then the GTM is out of the picture. It's like that. Then similar to the usual DNS server, GTM does not provide any port information in its resolution. It doesn't understand any port numbers and all. LTM doesn't do any name resolution and assumes DNS decision has been already made. So it is not a LTM's cup of it is not a LTM's cup of tea. Means like LTM's responsibility is to do the local traffic management. GTM responsibility is to resolve the name and giving it. That's why LTM will look for a GTM's help to understand the names and other things. When traffic is directed to the LTM traffic, LTM traffic flows directly through its full proxy architecture to the servers. It is load balancing. Since LTM is a full proxy, it is easy for to listen on one port, but direct traffic to multiple hosts listening on any port specified. So that is a basic difference between your LTM and GTM. In short, GTM for resolving addresses, LTM for handling the traffic. The next slide, we'll go to that. What are the products of the GTM? GTM products, we can go with an appliances like this, the small boxes are here, this like a hardware box we can take. VPN chases we can have, it's a long boxes because it has got so many line cards in that. And we can go with the visual editions also. Near about 80%, I can just say, of GTM is been involved, it's been installed with the virtual editions only. Virtual editions only it is been installed. Because we will be installing it in a VMware server or we'll be installing it in the cloud. Cloud means I can just say something about our cloud is AWS cloud, Azure cloud, Google cloud, any cloud, whatever you take that. That cloud informations are looking for VE only. VE means virtual editions. So there are many type of licensing available for the cloud licensing or private licensing or VMware licensing. So many things are there. fi.com, you can go and refer it. So FIGTM, the product we are installing mostly on virtual platform only. Okay. So we will be having some more information about this in the next coming slides. We'll see that. So this is about the blah blah about their own product. Okay, I just read it. Hyperscale and protect your DNS while optimizing global app delivery. Scaling and securing every environment helps protect your business from outages, improves DNS and application performance. DDoS attack is everywhere there. We just seen it in ASM, Application Security Manager. DDoS means a distributed denial of service, like multiple attacks will come from multiple locations all over the world. So this DNS need to be prepared. That's what I was saying. If you attack a DNS server, entire network, entire internet can be you can make it down. Definitely, because people will never reach their servers at all. Because everyone is surfing it through by the name only. So if you touch the DNS server, everything is resolved, complete over. So that's why we just need to protect our DNS servers also. That is possible through the DNS. That is called as a DNSSEC. It is called as a DNSSEC solution is there. This DNS security solution is being integrated with the DNS, means FIDNS. We can activate this DNS security. So to avoid this, to survive in the DDoS attacks, we can have DNSSEC solutions. So this is about the product information. Let us go to the next one. Superior DNS performance, DNS firewall services, wide area persistence, IP anycast integration, DNSSEC protection, very important, always on availability, high speed login, DNS health monitor. Everything is available on the DNS. on the FI DNS. So firewall services, we just seen that DNSSEC and other things are there. And DNSSEC protection and firewall services, we can have it. Always availability, 24 by 7, your operations will never be stopped, because the only thing is that how many DNS servers we are going to map it out under the GTM makes sense, and the GTM will be working 24 by 7, 365 days connectivity. And it is having the health monitor also. We can monitor that completely. How does it, which server is getting completely overwhelmed, which server is having that less performance or something. Accordingly, we can replace the servers and other things. And high speed logging will also be there. How many people are currently resolving the addresses, that logging we can get that. Superior DNS performance and wide area persistence. We can have some persistence queries also, like it, we can see it that in the LTM, like persistence cookies and all, I can set that. The next one, speed and security. Scale as a group integrates with your infrastructure. These are like a product, like product portfolio. You can just see that. It is like a responses per second. They call it as like RPS. It can scale up to 100 million responses per second for the DNS queries, because it is very much required. We need to enter the site immediately. Even if it is a 10-second delay, people doesn't, like they don't have the patience at all nowadays. If they're typing, what is it, twitter.com, immediately it has to go. If they're typing google.com, it should go immediately. They need to have their answers like immediately. That is what everyone is looking for, that, so that this what is that, the resolution per second makes sense. 100 million responses per second that we do. And scale as a grow model, when the DNS delivery requirements is keep on getting more and more like that, so we can go with that centralized menus, advanced logging, statistics and reporting and everything. Single point of control is there, and integrates with your infrastructure here. DNS zone management solutions, high productivity, faster responses, protected DNS management. These are all there. Okay. Next one, key benefits. Hyperscale DNS up to 100 million RPS, protect DNS against attack and availability, improve global application performance, deploy the flexibility, scale as you grow and manage efficiency. Same thing. So this GTM, what all things it is going to do that, and includes the industry's most advanced traffic distribution capabilities to match the needs of any organization or globally deployed application. Round robin it can give global availability, LDNS persistence, application availability, geography, virtual server capacity, least connections, packets per second, round trip time, hops, packet completion rate, user defined QoS, LDNS ratio, kilobytes per second. So with the Big-Ip DNSSEC validation, administrator can easily offload and validate DNSSEC on the client side using Big-Ip DNS for resolving. So these are all the, what I say, advanced GTM load balancing. You can do the load balancing also. Means the GTM will be doing the load balancing between the DNS servers itself. So that's why we are introducing a DNS GTM before the DNS servers. Like that. So what all it can do, FI can do, the GTM can do for a global, and it can do a local, and it can do the cloud load balancing also, it can do that. So one by one we will be seeing it. Dynamic DNS architecture infrastructure. DNS is a technical cornerstone for the internet, but it has faced significant challenges in the growth and security. The internet depends on a DNS. When it doesn't work, neither does the internet. Today's organization depend not only on internet DNS, but their own DNS as well. And when their DNS systems are break, their applications are breaking. As sites and applications become richer and more sophisticated, the burden on DNS increases. For example, a modern web page, every image, ad button, widget, link, icon, other embedded in the content having potential IP address that must be looked up. It is not uncommon for a single page to require all the two different DNSs like that. So the top level page such as CNN.com requires 100 DNS lookups. A larger, more complex web means ever increasing DNS requests. That's why, see, so many servers need to get resolved. When you're typing a host name, it's not only just the CNN.com. CNN.com require 100 DNS lookups. 100 DNS lookup for one site for one person. Just think of CNN.com has been, accessed by billions of people all over the world. When they're accessing it, so every access has the 100 DNS lookups. So you require GTM for this. Between the proliferation and mobile devices and other ever increasing amount of the content on the web, DNS usage has huge increase in recent years. Meanwhile, DNS continues to be tempting target for the attacks. This was actually. And when they succeed in disrupting DNS, all external data centers are affected. Very important point. When the DNS server is attacked, everything is gone for wasted. Completely it is getting wasted. So this is a diagram of that how the GTM can be placed out. High efficiency, productivity, faster web browsing, improved multi-site application. We'll just see that one by one. FI global, local, and cloud load balancing. Global inbound DNS solutions for global organizations with multiple data centers and with an existing DNS infrastructure. GTM can provide a range of services from global service load balancing (GSLB) to full zone service with FI's unique DNS Express technology. And DNS signing is also been there. Local DNS is used for locally. If you would like to locally, you would like to monitor something like you would like to keep your DNS local. In the sense, you can go with the local DNS. Cloud balancing. We can go for the if you install your all servers on the cloud, either AWS or GT or Google Cloud or something. We can go with the virtual edition. That's what I was telling. This is global inbound. In your data centers, you can keep this. This is local DNS. This is for your local on-prem activity. This is for cloud. It's a complete cloud like cloud solutions you can have. So let me go to the next slide. Global server load balancing. It comes like this. This is the clients they are coming in and they're coming into the data center. This is the data center 2 and it can go to the public cloud also like DNS servers are here, application servers are here. Here sits the global traffic manager. When a client is putting the query, it reaches a traffic manager first, GTM. It forwards the traffic to the load balancers. Sorry, it traffics to the DNS servers, or then the DNS servers will be pointing back to the application servers, or it may be talking to the second data center also. Data centers, some servers are there, or it can talk to the public cloud also. Like the global server load balancing between data centers and cloud. It's like that. So this is GSLB. You can say. Now, how does it works? Round robin DNS load balancing has two significant weaknesses. First, conventional DNS server has no knowledge of health of the application, and that is a problem. So this identify the health of the servers itself. GTM considers health of underlying application and deliver only addresses for the healthy servers because it finds out the backend servers whether they are in a good condition or not. Accordingly, it will forward the query to resolve it. Else, it will not resolve it. Then many organizations now use geolocation data to connect users to the data centers closest to them. That's what I was telling that. Whenever we are looking for information from Bangalore, I may be looking for within India, or maybe just nearest to me, that is Singapore. I look for that. So this is a geolocation. This geolocation also can be configured in the GTM. And here the benefit in enabling technology, high performance GSLB given by the multi-core Big-Ip GTM. Scalable DNS offload, DNS Express, product which they are telling. Spread the load across devices, IP anycast. Securing the DNS queries, DNSSEC. Route-based nearest data center, geolocation. Complete DNS record, FI, iRule scripting language is there. iRules with that, iRules we can write a lot of things. It's like a shell script only. DDoS protection, DNS Express. Protocol validation, full L7, layer 7 DNS proxy. These are all there. And we're talking about the local DNS, performance, scalability, and security, which comes up in the mind. When you try to create your own DNS for local servers, local application servers need to get resolved by the names in the sense. We will make it up. The GTM can work for our local DNS servers also. Right? So it can give a performance, DNS queries up to 80%, resulting high performance. Scalability, needs of even the largest enterprise data centers, it can do. Security, it can do something on a cryptographically intensive services from internal clients, like that. So it is offering the DNSSEC also. We can DNSSEC, we can activate it on the local DNS also. Next, this is like how the enterprise local DNS will look like. And the response time 300 milliseconds mobile and 100 milliseconds for the PCs. Like that, the timing and all they are giving it here. Like how does it getting resolved? So like this is forwarding the query to the data center 2 and it is forwarding the query to the private and like this. This is a local DNS. In the local also we'll place it out. According to the query which is coming for the cloud means it will forward it to the cloud. If it for the another data centers means it will forward it to another data centers. Like that. Cloud balancing with the DNS and GSLD services. So this is about the cloud. SaaS, we are talking about everything as a software as a service, right? For example, I can just say Salesforce.com is a SaaS. Office 365 is a SaaS. Like many other SaaS are available. According to the projects which we are doing, that we will understand what all the SaaS are there. For SaaS, we can do the cloud balancing. Cloud balancing because SaaS is being given on internet only. Means only the cloud service providers will be giving the SaaS. So when you are connecting to the SaaS, we require to resolve the queries accordingly. So that is coming under that cloud load balancing. Extends the query management and caching to the cloud deployments, ensures DNS queries are efficiently routed to the best cloud, increases productivity with the DNS caching and fast application responses. These are all the GTM can be deployed in cloud balancing. What all we seen? We seen these three: global inbound DNS solutions, local DNS, cloud balancing. Three ways, three environment we can install the GTM. Okay, so and we just need to talk about that, which should not be left out at all. We have to talk about how the GTM can be deployed in mobile transmissions also, mobile core also. So now the MME is like that. MME, there is an explanation as well. Like so, this is like multi people like that. It comes in that. So we all know it. When it comes to the data, not all subscribers are same. Use varies widely from person to person. Some listen to music and watch videos on every device wherever they go. Others prefer to spend their time playing games, engaged in social media, sending email, and some even use their cell phones as well, phones conducting business and talking to the friends and family. Different subscriber user patterns produce uneven load on the elements of the packet core network. It's called as the packet core network, particularly the gateways. Traditionally, this problem has been addressed by purpose built hardware and ensuring that each gateway has ample spare capacity. Like that, it comes in the mobile network, you can just say. So we need to mitigate unwanted communication on your service network to keep your services at the peak performance for the best subscriber usage and service availability. Malicious communication from the rogue programs should be blocked. Many DNS having the DNS filtering, although it's called as the DNS firewall. Actual feature is referred as response policy zones. This will be here. I can just say this is a response policy zone. So the traffic is coming from the mobile dismiss, like somebody is chatting, somebody is doing some photograph, somebody is on the social networking platform, somebody is listening music, somebody is driving, and they try to find out that the route and wherever it is. It's like that. Somebody is connecting to the corporate network, something like that. This, how you clear this information, because so many type of traffic which is coming into that. This is the traffic, and this is going to be the solution. When the person enters to it, this is the mobile core network. Then he goes there. This is the FIDNS here. Like DNS authorized local zones, DNS caching service, DNS impact, something like web caching, video optimization, content slammering, and it goes to the internet. And here it goes like server A and server B, where it has to forward these queries. So this is how our solution is going to be like. Even for the mobile network also, we can install the FI to forward the queries to the proper informations, because the query can come from many part, and 80% of the network, the traffic whichever it is coming on the internet is from the, I can say it's from the mobile network only. So how to optimize it? We have simplified view of the core, which is a present 3G and 4G network designs. Now 5G is also coming up by the next year. So you will be having some more speed and performance and as well. That time you require to manage many DNS servers as well. So on the left, you can see the mobile device or a smartphone. On the right, you can see the packet gateways. This is what. This is like mobile devices, and this is packet core and other things. These are all gateways, service provider core network and internet. Now the device to get a connectivity to the internet, it needs to initiate the connection. In 4G LTE example, this is performed through the management mobility entity. That is what MME. That's what MME. Now you've probably seen that settings like APN, access point name, IPN does networks like where to connect it, like that. So this is where we can install the DNS GTM, so that it will be forwarding the proper queries to the servers, or it can be properly query forwarding to the internet. Like. And see, this is just a diagram which just comes in multi-core with a static DNS response. The person having the smartphone coming to this, and it goes to the MME. MME is nothing but a provider. Then it go to the DNS. The DNS resolves and giving it to them. These are all the packet gateways. Through this, they can reach the internet. This is a normal. DNS reply to the MME. IP address is B, IP address D, IP address C, IP address A. Means like there are 4 backend servers are there. Through that, the internet site can be resolved. Like that. The DNS server is pointing to that. But when it comes to the static DNS response, in the sense, it will be giving only the IP address to this guy. That's all. But when it comes to that, actually speaking, that these servers are completely overloaded. You see that the server C is completely overloaded, and the server B is also, it is nearing, and the server D is not at all having any queries at all. So to resolve this all problems of the load balancing, we can deploy F5. We can deploy that F5. So by seeing the traffic pattern on this ABCD4 servers, it finds out that the B is having the least something like that. It gives a DNS reply to that. So this is how, if a packet gateway fails unexpectedly, Big-Ip Intelligent DNS service identifies the unavailability and stops providing the DNS responses which contains a PGW IP address. Though loading data, the Intelligent DNS service provides answers to the most appropriate PGW in real time. Actually, the B has down. That's what it is informing. It is not giving the proper server. Means the health and status. It is checking the health and status. You just see that. Let me annotate. See here. This traffic is so heavy. Means it is completely, it is out of the network like that. So that's why this is informing that the B is unnecessary usage. Health, it finds out the health of the servers and it is avoiding the traffic to be forwarded to the server. That is what been done. So thereby we can decrease the OPEX. OPEX means operational expenses. Then we can create some kind of a ticketing mechanism so that the people will be getting about this, why the B is getting overrun or something like that. They can go and check the server health and they can release that from the network or something like that. They can do that. That is a further things. Like, so this is called as an intelligent DNS. So FI GTM, when we introduce in the mobile core also, it can find out that which server is overwhelmed, which server is having so much queries to be resolved, and which are the servers are quite free for that. It can come up and resolve the queries for the users and something. So this is intelligent DNS response can be given on packet core also. Whoever is in the LG, sorry, 4G, LTE and other people will understand packet core. And the next one. Okay, so we have seen a lot of information. We just need to see something about the certification also. FI has got so many certifications. We need to start with the 101. Okay, everyone has to start with the 101. And they can go to the 201 or 202. It depends on their own, like interest. So people who are in support and pre-sales and other people will go for a certified administrator first. They have to finish 101 first, then they have to go to the second step as 201. Then they can go to anything, like it is going to be the technical specialist. This is a technical specialist screen. Like 301 they can take for LTM. 302 they can take for DNS. 303 they can take for ASM. 304 they can go for APM. After finishing this, they can go to this step. This is the third step. Okay, this is third. Sorry, it's the fourth step. I can say this is the first step. This is the third step. Means, let me make it clear. This is the first step. This is the second step. This is the third step, and this is the fourth step. To come until this much of solution expert, you just need to clear 201 and any one of the specialists. Then you can come to this here. So now we are talking about the technical specialist only. So we have to take 101, 201, and 302. This is what we just need to take. The next slide will be giving you the information. See that. This is what I was telling. 101 is a mandatory. 201 has to be taken. You should be administrator CA. Then you can come to the DNS. That is Big-Ip DNS. 302 is the certifications. What all things we are going to see on this one? The 302. The pass exam will receive the FI certified technology specialist. People with this certification can have the fundamental knowledge of necessary to application delivery controls, application delivery engineers working with the Big-Ip DNS, including the ability to understand the basic operation of DNS protocol, deploy, test configuration, troubleshoot, remedy, and common misconfigurations. These individuals are able to explain the capabilities of DNS services to deploy applications globally. Okay, receiving FI CTS, Big-Ip DNS certification is prerequisite to be cloud solutions. Means like You can just go to the next solution. So this is the path for a certification. 101 has to be taken, 201 should be, these two are mandatory for any certification here. You can take LTM, or you can take DNS, or you can take ASM, or you can go for APM. Clearing at least these three, then you can go to the specialist like this. That is a certified solution expert. So this is about the informations I just shown you, and this is my contact information, very important. And you can contact me on this number anytime. My WhatsApp number I just given, my cell number I can give on that, and you can send me an email on this, and you can talk to me on a Skype. And moreover, very important that I used to update every other videos which are in the YouTube, so you can see those videos anytime. Okay, and in a week I will be updating this all new whatever the demos and solutions which I am making, that I will be uploading it, because I don't have a time much. Maybe like in Sundays only I will just used to do that. So now I am open to any questions on this things. Like you can ask me any questions if you have in your mind. Okay, you can ask me any questions. I am open to that. You can throw any questions. I am ready to answer that. Hello, anyone? Any questions on this? Anything you can ask me, no problem. I'll be able to answer you on certifications, on DNS technologies, on you know, many things I can just say, or you can even chit chat with me. What is DNS? How to configure that? How to go for the certifications? And apart from this five, I used to work on many other technologies as well: cloud, AWS, Google, and Azure, firewalls, Checkpoint, Palo Alto, you know. And I'm mostly currently working on a data center and ISP environment, so I can talk about MPLS, BGP stuff, normal routing switching stuff, you know. And I've been working with the Terraform and Ansible for deployment basis and other things. You can ask me any questions. I can wait for 5 minutes. Then I will be showing you a small demo on the Big-Ip DNS, which I have already installed in my own laptop. And Big-Ip can be installed in your laptop with near about 6 GB. If you have spare memory of 6 GB is enough. Better if you have that i7 installed in your i7 processor is required, so that you will not face any problems on the, you know, working and functionalities along with the Windows 10 or something like that. It's possible. So we can have that DNS configurations for a while. Just one lab I would like to show you, that is a recursive DNS server. We can make the FI GTM as a recursive DNS server. So when from my Windows 10 computer, when I try to resolve a name through the dig command or through the nslookup command or something, so that we can see the timing variations. When I am doing it without my own DNS server, it may take a lot of time to get query to get resolved. But when I am doing it through my the recursive DNS server, I will be getting the reply within a second, or even 0 millisecond also it will take. So I will be just showing in that practice, that lab to you, how to configure and how to query and other things, and all I'll show you. Before that, I would like to ask your questions on this. If you have any questions, you can ask me. And you can put your email addresses, and as well also, like if you have any email addresses, I can come back to you. I can provide your email addresses so that I can just, you know, get you all these informations to you, so that it's easy for me to talk to you later. Will not be disturbing you, don't worry. You know, I'll not be calling you like an institute people like, hey, are you going for this certification? We are giving that offer, something like that. No, I'll not do that. Just I would like to have some kind of, you know, some database like that, how many people attended and how many people are really interested to know that. So you can give me your email address at least. You can unmute your mic and you can talk to me anytime. I just waiting for your questions. Thank you. So I'm ready to conduct the FI LTM, GTM, and can you provide slides of this PPT? Definitely, I will give you. For that, I require your email address. That's why I was just asking you. If you give your email address, I will send it to you accordingly. Please provide your email address and phone numbers in the chat itself, no problem. Give it to me so that I can forward it. How do I know? Harshit, you know, for this demo, I would like to send it to the people who are, you know, who are interested. How do I come to know? Definitely, I'll send you this recording also. It has been getting recorded now. So I'll send you the records as well as I'll be sending you this PPT also. Okay, Shravan Kumar has given. Other people can give it, no problem. You will not be get disturbed. Don't worry here. I'm not I don't have a time at all to work like an institute or something. So don't worry. Yeah. Harish has given. Panja sir. Okay. Okay. Sushil. Okay. But better that if people are asking any questions and they are coming out with their own ideas, that how do they feel it about this demonstration on F5. I would like to hear from you rather than just typing on chat. Hmm? Don't hesitate and don't be shy to ask any questions. Any question you can ask me. It was a nice demo session. Shravan is saying, oh, nice. Thank you very much. But my mic is not working. It is just an excuse. I can just see that you're saying that mic is not. Okay, anyway, I can just take that. No problem. Don't worry. Just joking. That's all. Thank you. And other people can ask me any questions on this. Okay, if no questions at all, like I can have this chat copied and no problem. I just copied this, no issues. And if anybody want to give their own information, again, you can give it anytime on the chat, no problems. So let me go back to the, FI Big IP screen I would like to show you. Please tell me if you are able to see this. Oh, okay, it's logged out. I'll log in again. Password. Oh, password is secret. Nothing secret here. It's only, it's a default domain name only. Okay. The DNS is the one. I would like to show you some basic information about this. I'll go to this resource provisioning. I logged into my FI box, which is running on the VMware. Here it is running Big IP demo. Something is running. The name which I given for that. So here in the resource provisioning, first job is that we just need to activate this global traffic. You're seeing that? Let me highlight this. Then you'll see it. This global traffic, that is nothing but the DNS. This global traffic need to be activated. I just ticked it. It's licensed. So 30 days evaluation, 30 days eval copy is available. 30 days evaluation copy is available. Okay. No need to worry about that. So anyone can take this 30 days evaluation copy and you can download this OS also. It's a OA file is available. You can download that and you can install it in your VMware workstation. Then you can keep on working on that. Okay, it's very easier. It's very easy. It's a OA file means it will be inbuilt everything on this. We just need to activate this. See, I activated LTM. And for the earlier demo, I activated the ASM. Now I removed it because ASM eats lots of memory, so I removed it. Now I activated the DNS. Now I will go to the DNS. Once you activated that, then you will be getting this DNS, DNS section will come up here. This has got a delivery, listeners, profiles, load balancing, pools and nodes, rules we can write here, translation we can do, name servers we can maintain it, keys we can give it. That is a DNS sec, securing your DNS service link. This is for global server load balancing. Here we will be configuring the wide IPs and all. Zones, we can configure the DNS sec zones and zone runner we can run. Caches, this is for how much cache limit is going to be maintaining. Means like how many DNS server, how many DNS sites we are going to maintain that. Something like that, the caches will be maintained here. This is overall settings, delivery settings, JSLB settings, zone settings, and cache settings like that. So these four are very important for us. Once you activate this global traffic only, then only this will be coming up. So to how to configure this recursive DNS server, there are some steps there I'll show you. And this is the steps. I guess you all can see my notepad. Recursive DNS server. These are all the steps to create. What is the first step? We just need to activate the GTM module that we already done that. And creating the new monitor we have to do. And creating the pool, third step, creating the cache list, creating log publishers and the log configuration section, creating the DNS login from the DNS. Seventh is DNS profile. We need to create that. Creating a listener, that is very important question. That is a DNS listener is required. Then TTL is nothing but a time to live things, and it should be taken from the cache only. So after that, what is the last step? In the NS lookup, we can just do, and we can give the DNS server, which we set it up, the DNS server in the GTM. That we need to give that address so that our query will be given on this. And you can use the dig also. Dig will be telling you the timing. NS lookup will directly resolve the queries as well. And the last one, we can just say that from the Big-Ip Linux shell, we can log into the shell itself, the SSH you can do. And from that, we can use that WinSCP, that is a WinS copy, secure copy. We can copy it there and we can, uh, troubleshoot it with the Wireshark. That is possible. That is for people who are running any problems and other things. So now what I do, I will go back to the DNS and the steps, whichever it has been there. Let me show you the pools which I created, pool list. This is a DNS pool. In the DNS pool, the monitor I created already, that is called as a DNS monitor. Let me take the pen. It's easy. Pen is not coming. Okay, DNS monitor I created that. This monitor will be doing the monitoring operations, and as well as, let me go to the members. The members are, there are two members are there. One is a Opal DNS I created, another one is a Google DNS I created. Google DNS IP is 8888, Open DNS is a 9999. Whatever the queries which I am making it from the Windows 10, it will be solved through the either Google DNS or through the Open DNS like that. The port number is 53. Okay, and it is doing the load balancing method as a round robin only. It's a default, and the statistics I can go for it here. Some other things which I already tried it, so I can just do the resetting. Let me reset it. It may take some time. So now it has become all 0, right? So this is very easy to monitor that. Okay, clear all the drawings, and then it will be seeing that. See, you can see hitting where I'm hitting all the zeros here. When I'm doing the translation to that, we can come back and to see this domain, to see this particular screen, statistical screen. I can just see that how many queries are resolved, like that I can just see. Okay, and the important one, I can show you the DNS. The DNS delivery listeners, I made it. Through this listener only, we are able to resolve our queries. The IP address which I given it is like 192.168.1.65. I created that. It is running on UDP. Because DNS service queries are done on UDP only. Recursive listener. There's a name I just given it. And the address of the recursive listener VIP is 1.65. And it is VLANs on external VLAN only. It is going to configure that. Then its profile is created on my own recursive DNS on this. Protocol is UDP, definitely. Load balancing is through the DNS pool, which I shown you already the pool on this. iRules, I have not written that for this, and the statistics will go like this, how much statistics and how much traffic and other things will be showing on this. So what I'm going to do now, I'll go to the command prompt. I'll go to the command prompt, and we need to install the dig utility is there. The dig utility will be installed. It's easy. It's a free one. You can install this. Somebody is asking any question. Okay. Can you show the lab diagram? There is no lab as such in this one. Okay. One second. I will just show you like how I installed it. Let me make it in Paint. That's all I can do. Nothing else as a diagram here. One second. Please wait. So here, what I do, I'll make it as like. I'm sorry. No, okay, saying okay. Okay, nice. Let me erase this. This is not the one. Diagram is nothing as such. Let me make one small wait. This is a GTM it take this. This is going to be the GTM, and this is my okay, one second. For a PC, I'll take it like this. All star. I am the superstar. So that is a GTM like that. Okay, and this GTM is going to connect to the internet. Wow, great. This is internet. And let me make it out the names. It will be easy for you. This is internet, and this is my GTM. F5 GTM. I need to mention that. Okay, and this is my Windows 10 PC, Windows 10 client, and I am connected to this GTM. Okay, through the GTM I will be logging to that. And the GTM has got the, what is it? There is a Google DNS is there. Google DNS, DNS server mapped, and Open DNS. Open DNS I'll show you. Open DNS server is mapped. So these two are mapped servers inside. Whenever there is a query comes in from here, when I am typing like facebook.com, when I am making the query from this Windows client, it will forward it to the FI GTM. I will be querying it with the VIP. What is the VIP I configured here? 192.168.1.65. I will be mapping it to this. When I am searching it, I will map it to this 65. So because of the 65 containing two DNS servers already, this DNS server is 8888 and this DNS server is 9999. When I am making the first query, whenever the facebook.com, it is not at all queried by this guy in the sense, FIGTM, it doesn't have the record in the sense. When I am making this query, it goes to this and it will be talking to that, what is it? Okay, let me take this. When I am making the query, it goes here. Then FIGTM will try to find out any records it is having because this is a recursive server. Let me make it as this is a recursive DNS. This is the recursive DNS I configured. The mode I configured is a recursive DNS. Okay. Now so when it is coming to this, the GTM, first GTM doesn't contain that information at all. Who is facebook.com? What is the name of that? What does it do? It will forward the query through that Google DNS, or it can forward it query through the Open DNS. These guys will go and talk to in the internet, they will find out the servers and they will give back the record to the FIGTM. So once the facebook.com has got that information, for example, I just say facebook.com is true, I'm just saying 65.111.78, something like that. This is the IP of the facebook.com. When this facebook.com, this GTM has got the recursive DNS got this information, it will pass it to me back. It will pass it to the Windows 10 back. First query goes out and getting the information. Second query, if I am doing the same facebook.com again, it will not send the queries to this. It will send it immediately from its own cache only. That is the only called as a recursive DNS. Very simple. This is what the diagram. Are you clear? Is it clear? Nothing else, nothing else. That's all, nothing else. So it is recursive DNS in the sense it is going to keep the records on its own. First time query will always be sent out of any domain the person is searching. Second time the same query comes in, it never allows the packet to go out. It will resolve it inside and it will give it immediately. So I am going to show the same thing to you on the command prompt. For that we require the dig utility. Normally we do the NS lookup. NS lookup means name server lookup. It's taking time. So now if I'm saying facebook.com, takes a lot of time. Why so? NS lookup, go man, go. Facebook down, huh? I don't know. Let me do twitter.com. Maybe my network connections may be down. I don't know. It's being right. It's being taking too much time now. I don't know. Something happened. No servers could be reached. Okay. I will type it like a server 8888. Then I will try twitter.com. Now it's like, that's why I was telling that this is non-authoritative answer. You see, non-authoritative means this Google DNS doesn't contain the twitter.com authoritative information, no records as such. It doesn't have that. That's why it is saying non-authoritative answer. Now I'll try the other sites. Okay, now I tried some other sites, facebook.com. Now it is saying that facebook.com IP is this. This is how I'll be doing it with the NS lookup. Now I do NS, I'll do the digging. Dig facebook.com. This query goes out, this query goes out. Guess it is not working properly. Let me dig it with the 8888 only. At the server 8888. Now it's saying, see, you can just see the query timing. See the query timing. This is very important. This is the query timing. When I am putting the query, digging means domain internet gropper. That's the name of it. I tried to resolve the facebook.com through the 8888 Google DNS. The time which response is a 204 milliseconds. Getting that? Now I'll do the same thing here. This time I will try it with the some other site. I'll do it with the centos.org. centos.org. Now see, it's taking 935 milliseconds. You can just see this line. Query time 935 milliseconds. Now let me query some other sites, redhat.com. Anything you can do, 166 milliseconds. So the time is very much more. That's what. Now I do Microsoft.com. Microsoft.com. Spelling mistake. Then it will not work. Microsoft.com. How does it takes? How many it takes? In 984 milliseconds it's taking. Microsoft.com has got a 4 sites, 4 servers, around 5 servers which are responding back. The same information, what I am going to do, I will be digging it with my own GTM server. So I will do dig at 192.168.1.65. That is a DNS server which I am running on GTM. Now I'll type facebook.com. Now it's saying first query it is saying that 180 milliseconds. Correct now? When I am querying again, see that 2 milliseconds it is taken. You see the difference? You see the difference here? 2 milliseconds is taken. So now I will do other site. If I try again the facebook.com, it will say 0 milliseconds. Now it is 1 millisecond only. If I am trying again, 1 milliseconds. It doesn't take much time at all. That is a what do you say? That is the functionality of our Twitter.com. First time it took 229 milliseconds. Now second time if it will take, it will come with only 2 milliseconds. This is the function of our GTM recursive server is. The recursive server is working over here. Let me go to that traffics and I will see full list. Let me see the traffic here, like a statistics. Now this much has gone, like near about 1 that is gone. It is actually talking to the open DNS only. It is talking to the open DNS only. Google DNS is out. Actually, I guess something it's not working. Now let me go back to the DNS and I will go to the listener list. In the listeners list, I will see the statistics. See this. Here it is coming. 5.4K. So initial response will be taken through the Google DNS, or according to the diagram, I can just do the initial response will be through this, and after the response will be on this recursive DNS. So this is how I configured the DNS server. Like that, we have so many practices are there, still there. There are so many labs which we will be seeing it through the GTM. We will be configuring the wide IPs. We will integrate the two LTM towards this, and we will be configuring the servers inside, and we will be doing the load balancing between the LTMs itself. It is possible, like many things which we will be seeing. Okay, so I guess I'm open to any questions on this. So I given some small demo also, like for the DNS which is running on that. It's a recursive DNS server. If I can if you can ask any questions, I can answer you. So I'm open to all the questions as well. Hello, please ask me, no problem, anything. It should be an interactive, then I'll be interested. No questions from my side. Okay. Shravan is saying no questions because Shravan has asked already the lab diagram and other things. Other people ask any question, no problem. See, DNS is quite common. Everybody is using in the daily life. So you will be having some queries on DNS as well. You can ask me any question, no problems. So I'm giving you 5 minutes because we are already past 1 hour, I guess, for this demo. It's going on continuously. Anyway, I'm okay. I can sit with you guys, not a problem. Is wide IP is the DNS IP? No. Wide IP is not the DNS IP. Wide IP is going to be the listener IP. It is called as a listener. It is like a listener. It comes like wide IP. Wide IP is not the DNS IP. What normally we do, we will map it out like a DNS like that for our people like. But wide IP cannot be given to the customers or not. Wide IP will be giving it for the internal servers which we are going to manage, that will be managed through the wide IP. Like that you can just see somewhat, here and there it will come up like. Any other questions? Listener IP, wide IP. So many new terms will be, you'll come to know that. Okay, any other questions like? DNS query is actually answered by the wide IP only. So you can call it as like a wide IP is also DNS IP, but actually technically you should not say that as a DNS IP or something like that. But actually we name it out like that because original DNS servers are behind and original LTMs are behind and the LTMs which are talking to the DNS IPs are application servers like that. So there is so many kind of infrastructure architecture is there inside so that you can just say. So any other questions on DNS? DNS is not so hard. Don't think so much heavily because it's in a production. Maybe like in production, each and every network is very critical only. So don't think that DNS is going to be so much critical now. But DNS problems when it comes like you will go mad. That is for sure. So you should be configuring it properly so that it will be giving the proper records. Otherwise, it will take its own time to resolve everything. Then the people will be start complaining that why my internet is not at all connecting. So you may be worrying about that, like, oh, the link is beautiful. It is giving the good download speed around. Why the people are not getting resolved because of this DNS problem. So DNS troubleshooting that all has to be done. But once you learn this FI, GTM, and DNS concepts and all, it's easy for you that you can work on DNS servers also. But mostly what we do, mostly people mostly like they'll be using the Windows DNS servers or the Linux DNS servers like that. So everybody has got their own DNS servers. Main proper DNS server in the sense like small DNS server means mapping that with a notepad we can just say that IP address to the names. That is a DNS. That is a host file. We normally say etc host file is nothing but a DNS file. I can just say, but it is not a DNS file. DNS like we require. What is the cost of certification? Cost of certification is coming around 175, I guess, $175 something like. Let me show you that information also. Let me go to the fi.com certification. FI certifications here. It's here, and you can find out that maybe like around $200 must be because all the certifications are like $200 only. It takes a lot of time because I am running my own GTM and all. That's why. Certification levels, certification requirements. From here only, I just pick it up that informations. Like a register, policy and program details. Let me go to this. That is not so good today. Anyway, what article is coming up? You can even see it, but it will be minimum like within 200 only. Okay, $200 maximum. So write on exam day, something like that it goes. Like scoring, reading, and all they're saying. Exam study material. Maybe some other site will be there. Candidate portal we may have to go for it. Like, you can find out the minimum. It will be around 200 only. Don't worry, not more than that. But only thing is that we just need to pass through that information properly. Then only we can get into that. So this information is important. 101 and 201 is required so that you can come to the DNS. You cannot just directly jump into the DNS. That's not possible. That information is there. So any other questions from your side? Just go to fi.com and you can find out that information. Advance your career. FI is number one in the market, definitely. FI certifications are very much valid and it is very costly. You can demand more salary when you are FI certified as well. Try to go for a certification as well. and try to find out if there is any dumps available in the market so that you can clear the exams as well. Like that. So any other questions on GTM like that? Or anything on FI, LTM or GTM or ASM or any other questions on this you can ask me. Okay, I guess no questions at all, so that I can go ahead and close this meeting because it is taking time. And thanks for all the people who joined. Thanks for all. And how GTM works only for selection of specific graphical location? It's a good question that we need to map it out properly. That is a geolocation configuration is there. Geolocation configuration, I can do it. That is a filtering we can base it on. Filtering I can made it based on the country-wise specification. I can do that. It's possible. There is a setting up is there. That comes under the configuration lab. Geolocation you can configure. Yes, that's what Pawan asked. And thanks for the people who are logged into this today. And you had a good sessions. And I had some questions also from the people. Thanks all. Thanks for all joining. And if anyone missed the email address or phone number, please give it to me. I will send you these recordings and like the PPTs as well. And about the updates, I'll be giving you like any new certification has come up, and any kind of changes happened on the any certification side or something, or any new chapters added to that. I'll be giving you proper updates on this. And I'm running a group called Ramnet. You can join in. It's a group name is called Ramnet in WhatsApp. You can join in that group. So I post some jobs also there. Yes. Please subscribe this channel as well. Okay, this is yours, huh? Okay, I will do that. No problem. I'm not. Oh, this is my this is my channel. Okay, yeah. Thank you, Sravan. Thank you. Oh, okay. I just seen the name just now only. Okay. Yeah, you can. Yeah. Anyway, it is there in the PPD. youtube.com/c/Ramnath Daske. So Ramnath Daske. So we can just see this name and they can just click on that link so that you can able to subscribe to this channel. And I will be updating weekly. Maybe like I try to make some more videos and I'll put on some technological videos as well. And I'm updating on this quite often. May not be so regularly, but quite often I just do that. Please follow me and you can subscribe it to that. And you can join my future demos and speech as well, technical talks as well. And if you guys are providing any kind of demos or talks or something like that, do drop in. Like you can intimate me. I can also join to your place, and I can listen to you people. Not only me, I will be always talking about that, but you will also give me some kind of technical things whichever you come across in your company or something like that, project or something like that. You can share it with me. And if you have any channels or something like that, please put it on the chat. I can join there. I can watch your videos as well. Okay, it's going to be more of interactive things and all. Okay, then I guess no more questions as such. And thanks for joining again. And I'm closing this meeting. Thanks all. Thanks a ton. Bye. Bye all. Okay, I'm ending this meeting.